Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Martin Casado and Sarah Wang from a16z's present an economic argument that challenges conventional bubble diagnostics. Their central thesis: the AI hardware market operates under inverted supply-demand physics compared to historical infrastructure crashes. They trace this logic through disposable custom silicon economics and the capital concentration threat to the application layer. Their framework suggests compute abundance eliminates traditional market friction. Here's their detailed case. Martin Casado and Sarah Wang from a16z's have constructed an economic framework that dismantles standard assumptions about market bubbles, hardware, amortization, and software platform dynamics. Start with the bubble comparison. The reflex assumption is that today's GPU accumulation mirrors the 2000 fiber optic overbuilding. Casado identifies a structural inversion. The dot-com crash resulted from infrastructure preceding demand. We constructed thousands of miles of fiber that sat unused, creating what became known as dark fiber, a massive supply overhang with no immediate consumption. His assertion is that today's hardware market exhibits the opposite physical reality. There are no dark GPUs. Every unit brought online is immediately consumed. The infrastructure is not a road waiting for traffic. The infrastructure is the product itself. Capital converts directly into intelligence and tokens that are consumed at the moment of production. This suggests that traditional bubble metrics, which identify supply gluts, are structurally misaligned with the current hardware consumption model. This observation connects directly to what they term the capital flywheel. Traditional venture capital operates on a multi-year cycle: raise funds, build product, scale sales, then raise again. Sarah Wang and Casado describe a compressed loop that threatens the entire application ecosystem. A model company can now raise capital, deploy a team of 10 to 20 engineers, and release a state-of-the-art model within a year that generates immediate, substantial revenue. This enables them to raise 3 times the capital in the subsequent round. The scale implication is severe. Casado suggests a single frontier model company could eventually raise more capital than the aggregate value of every application built on its platform. Consider the structural consequence. If the platform controls more cash than the combined market capitalization of its ecosystem, it can outspend any application to replicate features. This violates the Silicon Valley assumption of platform application separation. The platform becomes gravitationally dominant not through anti-competitive behavior, but through sheer capital mass. The software market consolidates into an oligopoly by financial physics. Shift to chip manufacturing economics. The semiconductor industry operates on the principle that custom ASIC design is a multi-year, high-cost process reserved for long-term, high-volume use cases. You do not design a custom chip for a single software release. Casado argues that AI training costs have inverted this engineering calculus. When a single frontier model training run costs $1 billion, the economics change fundamentally. A custom chip delivering 20% efficiency improvement saves $200 million. Since the cost to tape out a new chip is approximately $200 million, it becomes economically rational to design a disposable chip for a single training run. Hardware transitions from a durable platform to a consumable compiled alongside code, a complete inversion of traditional semiconductor economics. This cost barrier destruction extends to creative asset production. High-quality 3D environments, those used in video games or architectural visualization, typically cost thousands of dollars and require weeks of skilled labor. Casado points to generative AI and Gaussian splats driving the cost of a photorealistic 3D room from $30,000 to under $1. This represents a deflationary collapse of 3 to 5 orders of magnitude. When marginal asset creation cost approaches zero, the business model shifts from creation to curation. The traditional assumption that quality requires time and money no longer holds. Quality becomes infinite and free. The constraint is the prompt. Finally, examine the vertical AI thesis collapse. The consensus for years held that AI would evolve into specialized verticals: medical models, legal models, coding models. Investors allocated billions to these vertical AI strategies. Casado and Wang argue the market has invalidated this hypothesis. The counterintuitive discovery: there is no such thing as a coding model. There is only general intelligence. Excellence at code generation requires logic, ambiguity, handling, and human intent understanding, the identical capabilities needed for poetry or medical diagnosis. Specialized models failed because the best coding model is simply the most intelligent general model. This forces abandonment of the tools for task mental model in favor of a reality where a single, massive, undifferentiated intelligence outperforms specialized tools at their own domains. Casado and Wang demonstrate a consistent analytical approach. They systematically discard human-scale intuition in favor of capital physics and computational limits. Whether examining disposable custom chips, creative costs collapse, or capital centralization in a single model, they describe a world where traditional business friction time, specialization, and supply constraints evaporates under pure compute. The unresolved question is whether economic structures can survive a reality where the platform holds more value than the entire ecosystem constructed upon it. If you're interested in the video featured in this episode, click the link below to watch the original.